Welcome back to another Next-Gen Manufacturing Explainer. Today, we're diving deep into something that's in every single machine shop, a force that can literally make or break your precision, your tool life, and yeah, even the profits. We're talking about tool runout.
Let's just jump right in with the big question. What if a wobble, so small you can't even see it with the naked eye, is the real reason your tools are breaking way too often, your parts are out of spec, and your shop is just bleeding money? Because honestly, that's exactly what's at stake here.
You know, this hidden force, this tiny little wobble, it has a name: tool runout. It's kind of like the invisible enemy of precision machining. So, our goal today, we're going to make it visible, we're going to make it understandable, and most importantly, we're going to make it manageable.
Okay, so let's get a clear definition here. What is tool runout? Well, simply put, it's a measurement of how far a tool or any component is spinning off its perfect true center. Think about it like this. You could measure an end mill while it's just sitting there, and it looks absolutely perfect. But the second it starts spinning at thousands of RPM, that tiny deviation creates a wider, wobbling cutting diameter, and that's where the trouble starts.
Now here's where it gets really interesting. Runout isn't just one single error from one place. Nope. It's a cumulative problem. It's like stacking errors one on top of the other. You start with just a tiny bit of runout from the machine's spindle itself. Then you add your tool holder, which has its own tiny error. Then the collet, the sleeve that grips the tool. It adds a little bit more. And then, of course, the cutting tool itself isn't perfect. By the time you get all the way out to the cutting edge, all those tiny individual errors have ganged up to become one much bigger problem.
So the takeaway here is pretty simple, right? You can't fight an enemy you can't see. Before we can even think about controlling runout, we have to be able to measure it accurately. This is, without a doubt, the first and most critical step to building a truly precise system.
And when it comes to measuring, we've basically got two main options. On one hand, you have the traditional dial indicators. I'm sure you've seen them. They're common, they're easy to use. But, and this is a big but, they have to physically touch the tool. That contact can actually push on the tool and mess with the reading, especially if you're working with fragile micro-tooling. Now, on the other hand, you've got laser indicators. These are a total game changer. They're non-contact, they're incredibly accurate, and really, they're the modern standard for getting a true measurement.
And hey, you don't have to just take my word for it. The industry itself is speaking loud and clear. When the people who actually make the tools are telling you to use a laser, it's because they know it's the only way to really verify the incredible level of precision their tools are actually capable of.
All right, so we've identified the problem and we know how to measure it. So now, for the fun part, how do we fix it? Well, it's all about building a precision system. We're going to focus on three key areas to get as close to a perfect rotation as we possibly can.
First things first, it all begins with the tool itself. You just cannot build a low runout system with a low-quality tool. It won't work. See, every single cutting tool has some amount of runout just built right in from the manufacturing process. That's a variable you can't fix, so your only choice is to start with the tool that has as little of it as possible.
And here's the number you should have burned into your brain: 2/10,000ths of an inch. A lot of high-performance tools today are manufactured with a maximum runout of 0.0002 inches, or even less. That should be your benchmark, not just for your tool, but for your entire assembled system.
Okay, next up, let's talk about how we're holding that high-performance tool. A common set screw holder, like you see on the left, it applies pressure to one single point on the tool. Just by its very design, it naturally shoves the tool's shank off-center. But check out a modern shrink fit holder on the right. It uses thermal expansion and contraction to create 360 degrees of perfectly uniform pressure. Gripping that tool dead on center, it's a world of difference.
And that same principle applies to the tool shank itself. The Weldon flat on the left, that little flat spot ground onto the shank, that's old technology. It was designed for those set screws we just talked about, and it was a known cause of runout. Now compare that to a modern system, which uses special grooves that lock into the holder. This gives you amazing pull-out protection without pushing the tool off-center. For next-gen performance, it's a vital upgrade.
Now listen, you can go out and invest in the best tools, the best holders in the entire world, but if you miss this last step, it's all for nothing. Cleanliness is absolutely everything. Think about it like this. A single metal chip, maybe the width of a human hair, if that gets between your tool holder and the spindle taper, it's like putting a rock under one leg of a table. Now imagine that table spinning at 20,000 RPM. That tiny imperfection becomes a massive, tool-destroying wobble. Every single surface has to be spotless, period.
So,
We've been deep in the technical weeds here, talking about tools and holders and measurement. But let's pull back. Why does mastering this invisible enemy actually matter? Well, it all comes down to the payoff for your shop's bottom line.
The benefits are massive, and they are direct. I mean, look at this. When a tool runs true, every cutting edge takes an even chip load. That dramatically extends the life of your tool. It lets you crank up your speeds and feeds for way better performance. And of course, it leaves you with a visibly higher quality surface finish on your parts. It's a win-win-win.
This quote right here, it just says it all, doesn't it? This isn't just some technical exercise to chase perfection. This is about real-world results that save you time, that save you money, and that make your entire operation more efficient and more profitable.
And that's really our ultimate goal here. Look, runout is never going to be completely eliminated. It's just a fact of physics in machining. But by understanding where it comes from and using these strategies, we can take it from being this major unknown problem and turn it into a small, predictable, and totally manageable variable. So I'll just leave you with this final thought to chew on. Take a really hard, honest look at your current processes, your tools, your holders, your cleaning procedures. In the world of next-gen manufacturing, where every single micron matters, is that invisible, microscopic wobble holding your shop back from its true potential?